Cumberland traffic, tow 4041 uniform, departing 1 lot glider south.
Very abruptly after leaving the spin in one direction, enter the spin in the other direction. So it's rather difficult to control, but then we came up with a different method.
This is Soaring the Sky, a glider pilot's podcast, coming to you from the Mid-Atlantic region here in the United States and bringing you great soaring content from glider pilots all over the globe. We now join Chuck and our guest pilot.
Thank you, Michelle, and thank you for everything you do for us here on the pod. We greatly appreciate it. Thank you for joining us here. Happy to have you with us for episode 112. Now, a lot of you have interacted with us on social media the last couple days, asking about that very unique glider we posted a picture of. Well, our friend Tom Coussens is here, and he has a lot more info on that. So I will let him take it from here. Tom?
Well, thanks, Chuck. I'm Tom Coussens, and I'm really glad to be able to discuss the AKX glider with Dominic Poppe, who is the project manager at Akaflieg Karlsruhe in Germany. And so we have all kinds of things to talk about here. It's going to be a fascinating discovery of a glider that I find amazing. With my background in aeronautical engineering and model aviation and full-size aviation, the view of the AKX is amazing. So welcome, Dominic.
Thanks so much, Tom. Really glad to be here.
Oh, super, super. So tell me, first of all, or tell us actually, what is an Akaflieg?
Akaflieg. I mean, name already sounds a little strange. It's a German. It stands short for Akademische Fliegergruppe, which translates to Academic Flight Club. And there are a couple of those in Germany, 10 to be precise. And so on one part, they're normal gliding club, but they're also a student club. So they're totally comprised of students who are keen to learn how to fly, but who are also keen to get their hands dirty and, get the whole theory of flying and gliding and building planes. So our motto is kind of like researching, building, and flying sailplanes. So we do the whole thing from the ground up. And we have this, you could call it like a cycle of researching concepts, then building them, taking them up in the air, flying them, and seeing what works, what doesn't, iterating, and so on and so forth. And there's a lot of trial and error, and it's a great starting off point if you're interested in aviation and gliding. And I personally think it's really awesome because there are so many freedoms. It allows you to do so much stuff, and you can experiment without any risks. So yeah, that's pretty much what Akaflieg is about.
So it's actually attached to a university in Germany?
Yeah, sort of. It's not like an official part of the university, but we are a recognized student club. Most Akafliegs, or at least we do, we get a building from the university, which is very nice of them.
Yes.
And yeah, we cooperate with many faculties and stuff like that. But yeah, we're completely independent of the university itself, so we can do whatever we want.
Oh, that's marvelous. Now, but because it is actually, as you say, it's a kind of an independent function of a university. Do the members, the students, actually obtain school credit for their participation?
No, we don't, unfortunately. It would be nice if we did. But there's still many opportunities where it kind of harmonizes. I'd say where maybe you can write a thesis for your studies and have that be on an Akaflieg topic. But other than that, we don't get any credit, no.
I see. Okay. What is a nice thing then is that the students more are interested just because they really want to do this as opposed to filling in a checking off a box or something like that. And yeah, that's excellent. So tell us briefly about yourself as relates to flying and how you became involved in the AKX project.
All right. So I started off 2012 with gliding. That was in a normal club and got my license 2015. Well, and actually in 2015 as well, I had an internship at Champert in Germany. And that was the first time I actually heard about AKX.
Wow.
So okay. Already before I started my studies, I was like very keen to get into it and looking forward to it. And yeah, 2015, I moved to Karlsruhe, started mechanical engineering, and yeah, even before my first day at uni, I visited the Akaflieg workshop, and yeah, I was hooked from there. And then, over time, responsibilities grow and stuff, and now I don't know, for maybe 2 years or so, or 2 years back, that's when I took over as project manager.
Uh-huh. So when will you graduate from the university?
Good question. Difficult to answer. I'm very, very likely next year, so 2023. It's now it's easier to say in January. I can say
Yes,
next
yes.
year, and it feels like it's not so far away.
Yeah, very true. Well, fantastic. Well, that's great. So here's kind of a question: designing and building a new aircraft, and that's what you guys are doing. It's a very complex process, and in your particular case too, looking at the videos. So the thing about it is that hands-on skills are gained during construction. That's how you do it. I mean, I've built a lot of things in my life, and you learn how to do things. So how does Akaflieg maintain progress when members are continually entering and exiting the program as they enter college and then graduate?
It's a big challenge at times, for sure. But yeah, as you said, it's all learning by doing. Like, we don't learn the stuff at university we do, or like at least 90% of it we don't learn at university, especially the hands-on stuff, of course. So it's it's mostly passed on over the generations. We try to have like some short internal courses, if you like, but at the end of the day, it's you gotta get in there and put in the hours, and yeah, if enough people do that, then the knowledge sticks around, and if people get lazy, then it gets lost. But yeah,
yes,
we can at most times we can manage it right, or if we do have some stuff that's lost over the years, then we try to acquire it anew, like with a bunch of old members that sometimes stick around in the area, or that we can call, or we have a lot of some contacts in the industry we can ask. So yeah, if it's lost, we try to regain it, but we try to not lose it in the first place.
Yes, well, I can understand. I mean, doing something like this, it's such a project that requires a lot of time and dedication. I can really see where, I looked at, for instance, my son was involved in robotics in high school, and he is in his late 30s now, and he's still very close with people who we worked with in high school on the robotics team. So I'm sure that probably is the same thing here. You have people who just have Akaflieg in their heart,
Totally.
and they wish to help out wherever they can.
Totally.
Oh, that's really marvelous. That's great. So, as far as the design concepts and assembly, are all the efforts done through the Akaflieg members? You have any kind of external design groups or anything like that help out?
So design is 100% in-house. We
Outstanding.
That's from the ground up. I mean, of course, we get inspiration from other aircraft or from our own aircraft that we built previously, but design-wise, it's all 100% ours. That's like our main competency, if you like. That's the whole point we're doing this.
Yes.
As far as building the stuff goes, we build as much as possible in our workshop. All the fiber composite stuff, that's all we do. All of that ourselves. We try to create the molds ourselves as far as we can. If they get too large, of course, we can't do that. And we try to make most of the metal parts ourselves. But as soon as it gets to like CNC stuff, that's where we have to give it to someone else because we just don't have the machines for that. On occasion, we sometimes take like whole assemblies from different gliders, like, say, for example, in the case of the AKX, the speed brakes are just complete part as is off the shelf, and we just put that into the AKX since it wouldn't make sense to reinvent the wheel. But yeah, everything else, it's completely our design and work we put in.
Yes, that's what I sure noticed. Your videos, by the way, I just want to say, as an outsider, your videos are marvelous. They are so great to be able to see what you guys.
Thank you so much.
They're exciting. The the interviews with the various students that are in charge of things. I just keep it up. They're fantastic.
Thank you.
Wings and Wheels has been serving the soaring and sport aviation community for over 30 years. They hands down have the largest and most comprehensive inventory of sailplane and soaring supplies in North America, and they ship globally. Nearly everything you'll find on their site is in stock and ready for same-day shipping. Wings and Wheels is the exclusive American representative for HPH sailplanes. Be sure to check out the Twin Shark, their latest launch. They are also now the exclusive distributor in North America for the new Just Soaring Sim Pro. The team has thousands of hours of flying experience in gliders and airplanes, staffed by Adam, Kelly, Julie, and Sean. A friendly voice will answer when you call or email. Check them out at wingsandwheels.com.
So first off, we'll go ahead and get into the design of the AKX, because it is a wonderful departure from conventional sailplane designs. Was there a particular mission statement or theme that has carried you guys through all of this? Because it has been a tremendous effort as far as design and development. Was there some sort of a goal that you looked at? Is there something on your wall or something that basically says, keep it going, don't stop, or something like that?
Not in the traditional sense, like we don't have a mission statement plastered on the wall, if you like, but I personally think it comes down more to personal motivation. That's different for each person, but I can talk about what my motivation is behind it, and there are many aspects to it, but one part is that the Akafliegs, or we as a group, we're pretty much the only organization that can pull off a project like this, with maybe a few exceptions. Like, take your normal glider manufacturers, they couldn't do this because it's way too risky for them. They would have to put way too much money on the line, and they have their proven concepts, so it wouldn't be worthwhile for them. But for us, it's different, because we can just give it a shot, and if it doesn't work out, so what? Then too bad. But it's not like the whole company is on the line. And take like the big, research organizations. For them, this is way too niche. On the other hand, so we fall right in the middle of doing a project like this, where few others could even attempt something like this. I mean, there are a couple of exceptions come to mind, like maybe Paolo Iscold with his Nixus project,
yes,
or Gerhard Weibel and Dick Butler with the Concordia. But those are far and few between, and so at the end of the day, it's us who are doing this, or
nobody.
I guess no one else. Yeah.
Well, that's marvelous. I just hope that the Akafliegs, just all of them, I hope they just continue on, and as you say, you can explore things that would not really be viable on the commercial side, and not really something that is of interest in other things. I mean, for the most part, this is really all about research and design and what could be better.
Yeah.
So that's the one thing. The AKX is compared to another flying wing glider. I looked at the videos about the Akaflieg Braunschweig SB13, which flew in the 80s and 90s, but there are significant differences. So would you describe the overall configuration design process that led to the final configuration? Because several swept wing canard powered aircraft that have been very successful, like the Very Easy, the Long Easy, the Cozy. What drove your design to just omit that separate attitude and pitch flying surface near the nose, which is called a canard?
So first up, SB13, definitely a very big inspiration for the AKX. In the beginning, so this was before my time actually, 2010 is when the first ideas around the AKX started. There were a couple of concepts floating around, like back swept or no sweep or forward swept. But in the end, the team back then settled on back swept wings, since it seemed aerodynamically the most sensible, and also because the SB13 was such a great predecessor. And yeah, well, I mean, the SB13, I mean, it flew all right. It had some problems, but overall, it did pretty okay, especially considering how innovative of a project it was. So in the beginning, they did take the SP13 concept and try to improve on it. So that's mainly that it has a much stronger back sweep. SP13 had 15 degrees, AKX is up to 25 degrees. And with that, we get much higher pitch damping, which is really what caused a lot of the problems of the SP13. That was just kind of hard to control as far as pitch goes. And also what's new in the AKX is that we have integrated flaps, which the SP13 didn't have at all. And also the whole concept of the controls is totally different. So SP13 had only one aileron elevator mixed on the outermost section of the wing, and the AKX now has flaps over the whole span, and elevator is innermost and outermost, so they move in different directions to each other, and then the aileron also over the whole span of the wing. And that gives us a key advantage over the SP13, is that it's aerodynamically much better for the wing profile to not have to accommodate such strong elevator movements, especially if you're in slow flight. You'd have to continuously have that flap, at an angle, which of course aerodynamically for the profile, it's not designed to be flown continuously with the flap extended. So yeah, having this new configuration, we can fly the plane at much better much better configuration at most speeds.
Oh yeah.
Yeah, and there's compared to the SP13, there's a ton of changes under the hood. If you first look at it, it looks kind of similar, and of course you'd be forgiven to think that, but this project is from the 1980s, and really just like the whole industry has come a long way since then. CAD design was in its infancy back then, right? So we of course have totally different tools we can use. We have different materials. Also the science behind it has come a little further.
Yeah, for sure.
Yeah. So we hope to improve on
definitely.
A lot of things
That, as you say, because you're doing all of your mechanical design on CAD. Of course, there's also, you can do computational fluid dynamics to take a look and actually examine airflow.
Yeah, of course.
And that kind of stuff is readily available in open source, which is marvelous. The sort of things that you guys can do is far better.
Coming back to the Canard, because you mentioned that just now, it's simply in the AKX with the design we have with the wings swept back, it really wouldn't make much sense to include a Canard because, frankly, you'd have only disadvantages from that. You get turbulent air hitting your wings, and with the design we now currently have, it should handle mostly or like relatively comparably to a standard glider. That's the beauty of it, that we get a relatively standard plane, hopefully, but with the advantages of reducing a lot of the drag that comes from having that whole tail section and integrating those surfaces that, of course, are still required to control the plane, integrating those into the wings, into the winglets, and that's pretty much the key advantage there.
Yes, yeah, I can see that. I truly can. As you talk more, it begins to really dawn on me a little bit more, and that's what kind of leads me into that next question that I'd like to ask is, with the swept wing design and the center of gravity being in mid span, you do have an interesting challenge for pitch control where the wing surfaces range from forward to after the CG range, and so, a simple design concept would be to control the pitch from near the wingtips, or from near the wing root. But you actually did both, which is really stunning. And so, what factors actually drove that? Because I don't know if I've seen any other kind of an aircraft that has pitch control on both sides of the center of gravity.
Yeah. So that's pretty much some of the points I mentioned just now. So. In essence, it's advantageous to spread out those surfaces, and especially like in the different speed configurations, if you combine that with flaps, then you have the advantage of not needing so much elevator movement at all, or not so much angle in your elevator surfaces. And of course, I mean, anyone who's flown a glider for some time would probably realize that, playing with the elevator up and down, it's not going to get you a good glide ratio, because it messes up the whole aerodynamics. The profile of the airplane is designed to work in a certain way, and if you start moving your control surfaces too much or having them at an angle the whole time, then of course they don't work as expected. So by spreading this out, by spreading out the elevator, we can essentially operate the whole wing. We can have a good lift distribution that's not as affected by elevator controls, by different speed configurations, as the SB13, for example, where you would get very strong changes in your lift distribution. And of course, you always want that in a traditional aircraft design to be as elliptical as possible for maximum efficiency.
Just for one moment, but as far as lift distribution, I just want to make sure. So yeah, what we're talking about is actually the amount of lift that the wing provides from the root to the tip, and that if you look at a kind of a vertical sort of view of it, if you could see the lift, you'd actually see kind of an elliptical shape of that as the lift is much stronger toward the root, and it tends to tail off toward the tip in the shape of an ellipse. That's more for the non aviation design types. But go ahead. Thank you.
Yeah, and mathematically speaking, the ideal lift distribution is elliptical, right? As you just said.
Yes.
So
yes. Uh-huh.
We try to maintain that or the perfect concept would be having that lift distribution at every speed, which is practically impossible to attain. But I mean, as close as you can get, you're going to get better overall performance. So that's what we try to do.
Mm-hmm. Yeah, fantastic. So I guess we're going to basically leave some people here behind as we get a little nerdy, but that's okay, because there's some things I want to ask, or at least a comment. So, because what that does mean then is if you have, when you do have those control surfaces, pitch control surfaces in those locations, it means that you can generally have less deflection as well, right?
Yes, exactly. Yeah.
Outstanding.
And also one more detail, maybe a lot of people, when they hear of flying wings, they think, it's got to be a reflex airfoil for sure, which means the camber line goes below the which could be below the cord, right?
Yes.
At the back of the airfoil, and that's only required if you have a flying wing that has very little sweep, because you have to have a moment-free airfoil. But with our design, we can omit that, and we can have a relatively standard airfoil. And what this enables us to do is get this elliptical lift distribution that we just talked about, whereas another flying wing design that has a reflexed profile would have to have a bell distribution, which is disadvantageous for performance.
Yeah, well, I can understand that. That's fantastic. I'm just thinking of one particular glider, a relatively modern glider, which suffered a great deal because of that, because they had to have a reflexed airfoil. There were some huge drag issues at certain angles of attack, and so that you would basically eliminate that. That's fantastic. So yeah, we are definitely going to be leaving the the non-nerd types behind.
For that, that's just a quick excursion.
Yes, true. We'll try to keep it a little more basic, but I'm afraid
I'll try to keep it less technical. Yes.
So the control, and that's the thing. If you look at the videos and all the control mixtures there are control mixtures common in high performance gliders now that combine aileron and flap control. But in the AKX, as you've mentioned, you have multiple control surfaces on the wings that are actuated by a unique control mixture, which reflexes the entire system for thermaling and cruising, and yet still controls both sets of pitch controls and provides roll control as well. And so, it's exquisite. It's a beautiful design. And so, can you tell us just a little bit about the prototyping process that resulted in such an exquisite design? How did you arrive, and especially how did you arrive at the relative control surface deflections between those forward and aft surfaces?
Sure. So yeah, it is quite a marvel of mechanical engineering. It's not my work, but it's a couple of people on the team were involved in that, and at the beginning we weren't even sure if it could be pulled off, or if it could be pulled off feasibly, with with what we have at our disposal. But yeah, it is mechanically speaking relatively complicated. We have a parallelogram type of control, which means the stick doesn't tilt back and forwards. It moves back and forwards in parallel. And so it hangs on like a pendulum. And in that pendulum, we integrate the pitch control, roll control, and the flaps. And that then gets sent to the 3 control surfaces along the trailing edge of the wing. We sometimes jokingly call them flapper relevator or something along those lines, because they you have those 3 inputs, and they get mixed and they get sent to those 3 surfaces, but not always linearly and not always distributed the same amount. But yeah, the deflections are relatively straightforward, for at least as far as the elevator and aileron controls go. Those are 10 degrees up and down. And honestly, we pretty much arrived at that through like empirical testing of, just getting, especially with our scale model, we tested the flap deflections or the control surface deflections, and just checked what worked, since those are driven with servos. So you could tune them, see how much you actually need to control the plane proper. I mean, the final result will be out when we get into the air, if it's comfortable to fly. But I sure hope that those reflections should be fine, or at least they should be enough. But it's always very difficult to calculate something, or to calculate the deflection and be sure that it's gonna be the correct amount. So we kind of arrived at that by trying it out on the scale model.
Mm-hmm. Yeah. We'll get into that scale model a bit later. That in itself is just a fantastic way of testing out your concepts too. But that's great. So, well done. I'm certainly looking forward to seeing how it goes. So
we'll for sure have an episode on our YouTube channel in the future. I'm not sure when yet, but we'll for sure have one, because it's such a nice piece of the controls to look at, and you really can't convey how it works just by talking about it. You got to see it and see how it behaves, how it works with all the different inputs and outputs.
Yeah, that would be great to see. It truly would. Yeah, as you say, with it all working, basically looking inside at the mixer and then looking outside at the control surfaces and seeing how they're affected by different motions with the mixer. That would be fantastic.
Yeah.
Aerox, the #1 in portable and engineered aviation oxygen systems, your source for FAA-approved oxygen mask and portable oxygen systems, and now introducing the Aerox Pro 2 Plus Flight Bag portable oxygen system. Small, lightweight, and simple to use, the Pro 2 Plus is perfect for the occasional user who wants the flexibility to access higher altitudes without worry about flying impaired. Now available at Aerox distributors and at Aerox.com. So remember, our friends at Aerox, engineered for aviators.
So there's one thing I looked at too. The one thing that is unique about the AKX is that the wing actually joins what you can't even really call it a fuselage. It's kind of a pod, really.
It's tiny.
It joins it right at the very leading edge. Yeah, it is tiny, but it joins it. It joins it at the very leading edge of that pod, and so what that means is that it provides the pilot a unique view of the wing, which really is not available in regular sailplanes. In regular sailplanes, we can see the leading edge, and I have a PIC 20D, and I look out and see bugs on my leading edge, and I start cursing because that airfoil is not conducive to bugs. But in your case, or in the AKX case, the pilot can see most of the wing of the aft of the spar, actually. And so have you guys considered some form of airstream visualization, like with Tufts or something like that? So the pilot, just as we use yaw strings, would you consider maybe having some sort of tufting for flow visualization to keep the separation minimized during various flying regimes like thermaling or high-speed cruising?
That's a really interesting question actually, and no, we haven't thought about that. But I also think, I mean, our first goal is to get into the air, right, and to try out this concept and see how it flies. Also, I don't really see how we could integrate a flow visualization in a meaningful way that wouldn't cause additional drag. So, well, it'll probably be amazing to see the wings in front of you, and especially to see the control surfaces move as you move the stick. I'm really looking forward to that.
Yes.
I'm sure that will be awesome to see. But flow visualization, we haven't thought of that, honestly. And I at the moment I don't really see a way where we could do that efficiently.
Yeah, it's maybe not on a commercial sort of thing or whatever, but maybe just for your own benefit, just while you're doing your research.
Yeah, of course. I mean, of course, in flight testing, we're definitely going to do that. That's a standard part. Yeah, but that's not going to be something that we would have for later standard flights. I mean, It would be nice to see how, as you said, when you're thermaling, so you can get right up to that edge and no further. But yeah, that's going to be something for flight testing. We worked with yaw strings and like a petroleum paint for flow visualization in testing, but after that, no, I don't know. I mean, we're open. We're open to anything. We'll see, but honestly, I don't think there's going to be anything like that.
Oh, no problem. Yeah, it would be interesting to see how those all pay out as well. So now, kind of moving to something else. I didn't see a lot of detail on it, but your CG trimming concept, what you're doing in the tail cone, is fascinating. Yeah. If you can maybe kind of give it sort of a simple sort of overview, would be really good. Yeah,
of course. So we actually found out when testing the half scale model, or when designing the plane itself, we found out that it tends to be a little nose heavy, so we needed some extra weight at the tail. And since we're so space limited, there wasn't really any space in the fuselage, but we did manage to, essentially, the design essentially cuts off the whole tip, so it leads to a point. And we cut off that whole tip and replace it with essentially a steel block. So that's one part. It's a 10 kilogram steel block, so over 20 pounds. And in addition to that, we have space for some lead weights that fit into this block, and also in a tube that goes into the fuselage a bit. And so we can load up a total of 25 kilograms, I believe, which is over 50 pounds, maybe close to 60 in the tail. And yeah, but the interesting thing about the AKX is actually that the pilot sits very, very close to the center of gravity to begin with. So so our trimming, the trimming we do with that tail weight is a thing that you sort of set and forget. So it doesn't change when you change the pilot. It's we tune it once, or maybe change it depending on the conditions, but it's not like you would have to change that based on the pilot's weight.
Okay, so it's not flight adjustable. You don't need to worry about doing something like that. As you say, you find out what's optimum as far as flying qualities are concerned, and then you go no further.
Yep, pretty much.
Okay. Mm-hmm. So so now we'll move in.
And also to add to that, sorry, just one detail I just remembered. It's also for Flutter. Actually, it's very useful because it gives the whole fuselage and of course the whole plane. It gives it a moment of inertia that helps in reducing flutter.
Wow. Okay. Well, here at the risk of getting into the nerds again. So, but you're doing that because you have more of you have a higher moment of inertia, or at least a higher inertia for the fuselage itself. It's not so easily affected. Okay,
exactly.
got it. So yeah,
Yeah.
very interesting. So that really helps a lot. Okay, great. So I want to talk a little bit about that semi-scale model. The September 2021 video
Sure.
shows actually the thing that's interesting to me is towing this half-scale aero model with a full-size aero tow aircraft. That's wild.
Yeah.
And now, see, I'm a tow pilot. I fly a Piper Pawnee, and I've done so for quite a few years. And the idea of flying an unmanned glider behind me would definitely get me to be thinking. How did the tow plane? How does the tow plane pilot feel about that? I mean, have there been any excursions that were kind of difficult just because you didn't have a pilot in the model?
Well, first off, let me tell you, it was pretty difficult to get approval to do it this way. When we first started model testing, we actually towed up the model with another model aircraft. That was pretty easy to do, or to get approval. But doing it this way was really difficult because it's not normally meant to be done this way. But we managed to get it after a lot of time, and it is really quite a sight to behold. But to be honest, I heard from the tow pilots that is it's really not that big of a challenge, because I mean the model, it is relatively heavy. It's around 60 kilograms. So what would that be? Like, I don't know, 130 pounds or so.
Mm-hmm.
But overall, they don't really feel all that much from it. And also performance-wise, it's just like having a co-pilot. So we can rise up pretty quick in that configuration. And there have been instances where we decoupled, like the model decoupled from the plane, from the tow plane, and the tow pilot didn't even realize, because it adds so little drag and weight. So, yeah, I
can see that.
Relatively easy for the tow pilots, I believe. But actually, for the pilot flying the model, it's really difficult, because we don't use a like a headset or anything. It's all from the ground up, and we do go pretty high up to to have enough altitude for spin testing. So we go, I think, around 2,500 feet above ground, if I'm not mistaken, something around there. And yeah, all from the ground, just looking up. It gets quite difficult to judge altitudes, and especially to judge the difference in altitude between the model and the tow plane.
That's amazing. That really takes some skill on the part of the model pilot. My gosh, That's amazing. I know, because as a tow pilot, I've towed some pretty light aircraft before, like the Sparrow, which weighs like 200 pounds empty or something like that. And I've hardly even noticed it's there. So I can see that now. It would not be that big of a deal. It's just, it could be flailing around behind me and I wouldn't even notice it. So, on the other hand, towing the bigger ones, it almost feels like the tail is wagging the dog. So, but that's really good. So now, one thing, in that video with the aero model being spin tested, what kind of unique aspects, or were there some unique aspects as far as entry and recovery to get it to spin and to get it out of the spin?
Yes, actually, in particular with the exit out of the spin. So entry is pretty standard. I mean, as far as there's anything standard for spin entry, because every plane behaves a little differently, and you have different behavior depending on your CG, on your trimming. But yeah, as far as that goes, it's fairly standard. And getting out of the spin is where it starts getting interesting, because at first we tried the standard procedure, which is for the most part just rather in the opposite direction of the spin, right?
Yeah, and neutralizing the stick also. Yeah, neutralizing the pitch controls.
That of course.
Mm-hmm.
Yeah, of course. But the main force that's getting you out of the spin, of course. I mean, of course, you have to release the stick so that you don't go back into the spin, or that it's effective your exit maneuver. But the actual force that's getting you out of the spin is your rudder in that case. Of course, we tried that procedure in the beginning, and it really didn't work that great. It worked in some CG configurations, but we also had problems that it would sometimes very abruptly, after leaving the spin in one direction, enter the spin in the other direction. So it's rather difficult to control. But then we came up with a different method that works pretty well for the AKX, and I think it's really interesting. It's basically you push the stick forward in like a quick jerk because you're in the spin. That, and because the outermost elevator in the spin still has flow around it, so that actually causes a precession moment that then counteracts the movement around the vertical axis and stops the spinning motion most effectively. That's really quite interesting in my opinion, because it's not really intuitive at first.
Yeah. So you're jerking the stick forward, you're pitching forward, but because of the pitch controls at the outboard outboard set of the wings, as you say, because they're flying, it actually stops. It basically imparts roll against the spin, and is that how it's recovering?
Yes, and then on top of that, the precession moment, which we believe plays a large part in that, because you're
gyroscopic precession.
Yes, exactly, gyroscopic precession. Yes.
Wow.
Yeah.
Wow.
Because you're practically, I mean, essentially you're spinning around two axes when you're in a spin, and so yeah, you can use this gyroscopic precession effect to get it out of that.
That is fascinating. Fascinating. Yeah, you won't see that in standard aircraft. That's for sure.
No, you won't.
Amazing.
They have way too much rudder effect and the what you call it, the what you call the section before the rudder,
the fuselage, yeah,
like the
or at least
no, I mean it's the stabilizer.
Right, the fin and rudder, basically. Yes, yeah, the vertical fin.
The fin, yeah.
Wow.
So a standard plane has too large of a fin, and so of course you use a rudder in that scenario, but we have to use different methods.
Wow, that is fascinating. So have the pilots tried to thermal with it? You're thermaling, obviously you're doing it externally just as a regular model glider, but how well does it thermal?
Yeah. So there were some thermal tests actually, but only with the 4-meter wingspan model, which came before the half-scale model. And I mean, the pilots commented that it was pretty standard. It was fine. But then again, it's really hard to compare it. I mean, comparing the scale model with the full size model, especially when it comes to like flight performance and the details of handling, because I mean, if you're talking about good thermal handling, then we're talking about a lot of minor details that you would only really notice when you're sitting inside of it. But we're hopeful that it should be able to thermal really well. I mean, we have a couple of things going for us. So we have the large winglets with a relatively large winglet. A wing area, relatively large wing area, especially for the wingspan. And we have with this configuration, we have a relatively large rolling moment due to the yaw. So when you push the rudder, you also roll into the direction of the direction that you're pushing the rudder, and that combined usually results in characteristics that pilots would describe as good thermaling characteristics.
Yeah, the ability to thermal tightly.
And also performance.
Yeah, I mean the key thing is to be where it can really make a difference, of course, is in, say, light lift, where you want to make a very tight turn and be able to exploit the low lift, low amount of thermal strength, but you also need to have a fairly small turning radius. And yes, it seems like that would work very, very well to do that.
Yeah.
Our longtime sponsor of the show, the Soaring Academy, is engaged in nonprofit outreach work with local area veterans and also with young people for the STEM programs at their top-notch glider port facility just outside of Los Angeles, nestled near the north side of the San Gabriel Mountains. They also have a fantastic flight school and are continuing to turn out great glider pilots every month. If you like to donate to their nonprofit initiatives or learn more about their flight school, go to soaringacademy.org or check them out on Instagram at Soaring Academy.
So, how about during approach and landing? The one thing I did see, you definitely the design was affected by that, of course, because I saw where the wings, if they were positioned in a low position, then there were problems with the wingtips contacting the ground during the flare. And
yeah, absolutely.
Yeah. So how about that though? When you're coming in close to the ground and, short approach and landing, were there any unusual handling characteristics as you began to slow down and land? And how about reactions to the dive brake actuation? Was there any, was anything unusual there?
So yeah, funny that you should mention the low wing mounting, because that was actually the original concept, or that was how SB13 was laid out as well. But after the first couple of iterations, we realized that we really couldn't do it this way. We had to have like a mid wing configuration, or else we'd risk touching the ground on flare. And yeah, so that's quite interesting. Now we should be clear, hopefully, of the ground. And also, in addition, we have added, or we now have those flaps, and those obviously also help keep the plane more level when coming down.
Yes.
But yeah, with the model, we did have a couple of rough landings. We had like at least one broken nose gear, which is now reinforced. But yeah, that's where we hit a part where it's difficult to say how much we can compare the model to the final full size plane, because a lot of it, or some of the handling, or rather of the difficulties in the approach, could also just be down to the sheer weight and speed of the model, which standard aircraft models don't usually reach, or at least in that class, in that wingspan class. So yeah, it's difficult to say if rough approaches is gonna be a problem we will have with the AKX later on, or if some of the challenges we've encountered in model testing are just down to it being relatively heavy and fast. But yeah, that remains to be seen.
Yeah, and of course, Reynolds number could have an effect also. There's one for the anti-nerds, but there's that as well. Your model is going to be a much higher Reynolds number.
You're correct.
Full-size aircraft.
Well, I mean the Reynolds number is it was specifically designed, the model, to have a relatively high Reynolds number, in order to get as close to the characteristics of the full-size prototype. So completely discarding any performance metrics, but just optimizing for characteristics that are as close as possible to the full-size plane.
Yes, so you'd have to fly the model faster in order to approximate the Reynolds number of the larger aircraft, and so that gives you all kinds of other
fast.
problems.
I mean, it's still slower than the full-size plane, of course, but it's compared to its size, it flies pretty fast. Yeah.
Yes, yeah, that makes sense. So now you mentioned Flutter a little bit, and that I also saw that in the video about the SB13. Is Flutter a greater concern on a swept wing than a straight wing, and was Flutter encountered in the half scale air model flights?
Yeah, it definitely is a very large concern. A lot of the design hinges on Flutter. The issue that we run into is that the bending forces couple with torsion forces. So when the wings are bent up, inevitably you're gonna encounter a little torsion because of the back sweep, and that then, coupled with oscillations in angle of attack, leads to problems because of course that torsion that you encounter when you bend the wing also changes the angle of attack, and so it really is more of a problem in this design than in standard configurations. And also was a challenge that this Flutter mode happens very abruptly. So there's no real warning beforehand. It's you have very little damping once it happens, which is also different to standard designs. And actually, we had a 4-meter model that was probably, we're relatively sure, was destroyed due to Flutter. With the half scale model, we did some Flutter analysis beforehand, or like Flutter testing, as in you hang it like on you have like a fixture that you hang it onto, and then you measure the different modes. And we did that, and now we try to keep way clear of that critical speed. But also, the reason the 4-meter model was destroyed before was that we used a ultra high modulus fiber that, whilst it was very good for stiffness, it was actually too stiff, or too brittle, rather, and that is what caused it to be destroyed. And now for the prototype plane, we use a fiber in the spar that's also very, very stiff, but also has a high strength. And yeah, so that should be very sufficient.
Yeah, I saw. Well, the video of laying out the spar was really instructive. Was a great instruction. Very educational.
It's painstaking.
About that. Oh gosh,
painstaking, yes. I can tell you.
Yeah, because you're laying down individual strands all along the whole thing. Yeah. Holy smokes!
We stand there for like 10 to 12 hours, laying down individual strands, and we can't really take a break.
Yeah.
And on occasion we some of those we built in the summer, and it was pretty hot outside, so we had to do it during the night so that our resin wouldn't get too warm.
Oh goodness.
During the process, so we start at 10 p.m. and finish at like 7. That was quite a lot of fun.
Oh,
it's like 12 people around about.
Wow. Yeah. It's just very intensive, but yeah, as you say, you want to have the absolute, that's the only way to do it, where you basically have individual strands. You really can't afford to have any kind of a weaved spar cap. I can understand that.
Yeah. It's a very massive spar cap as well.
Yeah.
Very massive and very stiff.
Well, that's a good thing, because the key thing is it's going to be interacting with the control surfaces, and your control surfaces, of course, they're really critical as far as Flutter is concerned, and so you have to build them very light on the trailing edge, and well balanced, or you are going to be in big trouble.
Yeah, that's true. That's actually one more challenge we have yet to face, or we've gotten our feet wet, but we haven't found the perfect solution. We're still experimenting with building rudders that are as light as possible and still strong enough, but we haven't settled on a final design or a final building process of how we want to build these.
Wow, yeah, that's going to be key. I know that as far as balance is concerned, control balancing, I remember from my old aero modeling days of having very, very stiff and strong leading edge, and as far as knowing where to actually mount the hinge to make sure that the controls are actually balanced, and then the trailing edge portion has to be as absolutely light as possible. And of course, in your case, it can't flex too much, otherwise it won't be effective. And you definitely, it's a good thing for a dedicated group like the Akaflieg to be able to address, and that's great.
Yeah. We're definitely going to have a lot of trial and error still ahead of us.
Yes, I can see that, but it's all in pilot safety, really. It needs to work before the pilot can fly it. True. So that's good. One thing I saw also was there was quite a lot of emphasis on your stress testing, major components to failure, and that was very interesting about your wing and your rudders. Can you tell us a little bit about how that went?
So yeah, that's always a pretty big undertaking. I mean, you sometimes spend months building these parts, and then you see them be destroyed in a couple of minutes. It's like it's a bittersweet moment, because of course that's what you're working towards, but still seeing it get destroyed is it's interesting, to say the least. But so yeah, we've thus far the two biggest components we've tested is the wings and the winglets. Rather, we've done some preliminary tests, but not final yet. And of course, we test a bunch of like smaller components that go into the glider, like say like some control rods or the like. Those are all tested unless we can be like 100% absolutely certain, just simply based on material properties that they're gonna hold. If not, then we have to test it. So yeah, it's exciting every time. The wing, I mean, it's pretty big, and loading it up with so much force until it breaks, yeah, it's really exciting. So the process works, or what we have to prove is that we reach a safety factor of 1.725 on top of the maximum load that you could possibly encounter in flight. And yeah, we proved that with the wings and the winglets successfully. The wings lasted until a safety factor of 2.7.
Oh,
which
great.
I mean, yeah, well, I mean, it depends. If you look at it from the point of like say a structural engineer or the like, some might say, well, in that case, you built it way too strong. You built it way too heavy. But interestingly, actually, that you know, that high safety factor arises from the necessity of having to build the wing as stiff as we have to do because of the flutter that we mentioned before. And a side effect of having to build it so stiff just results in it being so strong. So going into that wing failure test, we never really doubted that it would crack the 1.725, but of course we didn't perfectly know what safety factor we would reach, and we learned a lot from that, and we actually improved this design on top of that even more, because we actually had a torsion failure, again due to that back sweep. You get a lot of torsion load on the shell, and we actually had a torsion failure at the web at the trailing edge, and that then transferred to the shell, which caused it to rupture. And for the winglets, we got to a safety factor of 2.2, which is pretty high, but it's also good to have that extra safety margin because they're just so massive, and you never know. I mean, if you end up putting them face on into incoming air, if you happen to maneuver the plane in such a way that you would hit the incoming airflow full on, then it's good to have that extra safety margin on those winglets as well.
Oh, definitely. Yeah. Hopefully you're never going to be at a 90-degree yaw, though. That's for sure.
Yeah. It would be quite. I don't know. It would be surprising because I really don't see how you could get it to that. But still, nonetheless, it's good to have that.
Definitely. So tell us a little bit about the progress of the full-size prototype, and outline the remaining tasks required until it makes that first flight.
Yeah, sure. So we actually started building like the structural parts way back in 2016. That was when we built the first parts that would go into the plane. And you know, it takes a couple of years. We only do this in our free time, but nonetheless,
Sure.
nonetheless, or actually for a couple of years now, we've completed the left wing and fuselage as far as the structure goes. There are still some finishing touches on those, but yeah, and then so those are complete, left wing and fuselage, and then we have many other parts that are very close to their completion. For example, the right wing, we just finished building the spar, and we're now going to move on to the controls. And in a couple of months, we're hopefully going to close those molds and close the shells. The undercarriage, so the forward and rear gear are design-wise, they're complete for some time now, and they're fully in the production process, and yeah, they're coming along nicely, and hopefully a couple of months we should have the rear gear complete. The front gear is going to take a little longer because it's a little more complicated because of space restrictions. Winglets are in full swing right now. We already completed the shells a while back, and now we're moving on to structural components on the inside, and also the controls. So those are like the main groups, and there's still a bunch of stuff that we have to do. So like the control surfaces I mentioned earlier, that we're still finalizing designs, and then a lot of finishing touches in a bunch of stuff. So we have hydraulic system on the plane to actuate the gears. We of course have electronics like any other glider. You gotta finish up the cockpit, and you gotta sand the whole plane and polish it, and then on top of that, we have a bunch of bureaucracies in order to attain our permit to fly, and that's gonna be a really, really big chunk of work still ahead of us.
You should have started those back when you were riding a bicycle with training wheels, huh?
Yeah, you could say so. We completed some chapters of that, but there's so much left to do. And also one key part we have to do before the first flight is our Flutter Test. So first a theoretical Flutter analysis, and then a Flutter Test similar to the one I mentioned that we did with the half scale model. So yeah, just to set the maximum speed. Right. That's
wow. Okay,
mostly it.
Lot to go.
There's minor stuff. Minor stuff left and right, but those are like the main things that we still have to do. So it's still going to be a lot of work.
A lot of work, but a lot of dedication among the members of the Akaflieg too, which is
absolutely.
I have a funny feeling you guys all probably spend long nights and maybe don't go to certain classes so that you can keep on working. I think I think that's probably what's going on a little bit now.
No comment.
Yeah. So tell me then, the plans for the full size prototype. Once the flights begin, have you begun to figure out a flight test plan?
Just Soaring, the makers of the Glider Sim Pro sailplane simulator cockpit, would like to congratulate German pilot Ben Fest for his recent victory in the first ever FAI-sanctioned aviation esports event in history, the Sailplane World Grand Prix, which Ben won after several days of exciting competition against some of the top Condor soaring pilots from around the world. If you are looking for a best-in-class dedicated sailplane simulator cockpit for Condor or Microsoft Flight Sim, look no further than the Just Soaring Glider Sim Pro. Check them out at justsoaring.com or at just.soaring on Instagram.
Sort of. I mean, a lot of it is laid out for us because it's required by the in German it's called Luftfahrtbundesamt, which is sort of like the Federal Aviation Office, if you like. They lay out the requirements that you have to fulfill, and those are pretty extensive. So yeah, those are first on the list. Pretty much the bunch of the time in the beginning is just going to be spent testing all the different aspects, especially those critical scenarios where you approach flight conditions that can be critical, like max speed or speed brake at max speed. That's also quite an interesting one. All those different tests. And that's going to keep us occupied.
Right. Yeah, that can be
longer.
Yes, just as they say, expanding the envelope, basically getting, and so that's where things get interesting.
True.
So with the aircraft, say that the AKX winds up being a real success story, and perhaps it drives Schempertz to consider something like that. Do you have any sort of thoughts about the future of the AKX configuration if it really does work as well as you are anticipating?
I mean, there's always talk, right? I'm so like involved in the project. Of course, we get crazy ideas and all that. We'll see. The next project after the AKX is definitely not going to be a flying wing, or I say definitely, but most likely. I'd be very much surprised if it's going to be another flying wing, but I don't know if it truly is very successful. We might do like an AKXB. We already thought about maybe integrating a electric motor into the back, because it's really well
Mm-hmm.
suited to have a small electric motor in the rear of the fuselage. Something you can't do with a standard plane. But yeah, as far as this
Right.
project goes, it's,
Yeah, the design looks like it. I'm sorry, it's a conical shape of the pod.
Yeah.
It looks like, oh my goodness, forget the CG, put an engine
Yeah,
back
yeah,
there.
true.
And of course, you could do that if with a set and forget. It means yes, you could actually mount some sort of a motor and battery, and then if you needed more weight, simply add it, and then you're all set to
Absolutely, yeah, you could do that, but that's of course for as far as we're talking AKX right now, that's just too much to handle because we already have so much going on. So we want to get it into the air first, and then maybe in the far future see if we can expand upon it, see if we can experiment some more. But the main goal is very clear for now.
So finally, I guess the last question I have is, I know you guys are very, very head down and concentrating on the AKX. Have you thought about the next project? What happens after the AKX for Akaflieg Karlsruhe?
Yeah, interesting question. So there isn't one set concept right now. There were some floating around, but for the moment we decided to concentrate our efforts on the AKX since we still have a ways to go. But there were a couple of concepts, like the one idea we thought of a couple of years back was building a motor glider that can act sort of as like a research platform where you can have exchangeable parts, maybe like outer wings, or you can have measurement pods or the like, or a bunch of equipment, or like essentially a platform that you can easily expand upon and try out different things, try out profiles, do free flight measurements and all that. That was an idea, but we're not quite so sure on that anymore because might be just a tad too big. We'll see. And then another idea that's floating around at the moment, but that was put on hold for now because, as I said, because of AKX, could be an aerobatics plane that handles nicely, that handles like a standard plane, but then at the push of a button you could maybe have some airflow, what you call it, like flow changing devices, like air pushing out of the wing, out of little holes, for example, in order to change the characteristics so that it would turn into like a really aggressive aerobatic plane that can do all sorts of crazy stunts. And then when you're done, you can go back to your normal peaceful plane and land it calmly.
That sounds really interesting. I wish I were a student. I'd love to go off and do that. Oh, that's great. Well, I think I just want to say what a pleasure it's been to talk about the Akaflieg and AKX with you,
Pleasure's all mine.
It's been, oh my gosh, and we look forward to seeing the progress, and wish you guys all the best. What a great concept you have, and I just want to say, just kudos to you and your team and the students that are coming in and going, and all the things that you're able to accomplish in that sort of an environment. And all the best to you, Dominic.
Thank you so much. Thank you for having me on. And as a side note, maybe to your listeners, if they're interested, like we mentioned a couple of times throughout this podcast, so we just started a YouTube series where we publish monthly updates, and that's especially for the English-speaking audience. I would recommend those highly because unfortunately our website and the rest of the stuff we publish, a lot of it is in German. But those videos, we put a lot of work into having good English subtitles, and so they should be hopefully enjoyable to all audiences. And yeah, we'll definitely keep everyone updated through that.
Absolutely. I just want to say, as a viewer of your YouTube videos and only English speaking, it's very well done, and I think it will be excellent for all those to see. So just the main thing then is just YouTube. If you just YouTube Akaflieg and KA, you'll get everything. That's all you have to do in order to see what Akaflieg Karlsruhe is doing there. All right. Well, thank you very much, Dominic, and thank you for plugging, which I should have asked you for in the first place. And I hope to we hope to certainly see progress in the near future.
Thank you so much.
All right. Take care.
Take care.
Okay. Bye-bye now.
Hi everyone, Sergio from Soaring Master here, with tips and advice about cross-country flying. And today we're going to talk about turn points. It's not out of coincidence that many pilots outland near turn points due to poor tactics regarding height, wind, and lift sources. 20 kilometers before the turn point, assess from which direction the wind is coming from. If you're approaching the turn point with a tailwind, look for thermal sources before rounding the turn point. As you stop for circling the thermal and climbing with each turn, the wind will carry you towards the turn point. Best thing ever. The opposite occurs with a headwind. Prefer rounding the turn point first and then in the next leg stop for thermaling, since the wind will carry you towards the next turn point. Another important aspect is height management. If you're approaching the turn point with a tailwind, make sure to do so in the upper height band, because once you turn it, you will face the wind and your effective glide ratio will decrease. So be sure to have enough height before turning the turn point, because otherwise you will have to look for thermals down below. Depending on the case, you might not be able to reach the next thermal if you don't have enough height. Always think ahead. That's the key for cross-country flying. For more tips, follow me on Instagram @SoaringMaster or check my website, soaringmaster.com.
If you would like to say hi and let us know where you are enjoying the podcast, we would love to hear from you. If you are a glider pilot and want to share your aviation journey, contact us at chuck@soaringthesky.com or send us a message on our website at soaringthesky.com and Chuck will get in touch with you. We hope you join us next time for another soaring adventure here on Soaring the Sky, a Glider Pilots podcast. Soaring the Sky is written and produced by Chuck Fulton, co-producer Mitch Thompson. Original music for the podcast was written and produced by Kim Spangler. Graphic design for the podcast was created by Zachary Fulton. Voiceover work was done by Michelle Perez.